This video series goes through the daily problems in this maths calendar that is published by the American Mathematical Society. You can either purchase it through their website or via Amazon. Today's question is to evaluate this trigonometric expression. To start off with, we need to recall what cot, cosec, sec and cot are. Hopefully we know what tan is. Cosec theta is 1 on sine theta, sec theta is 1 on cos theta, cot theta equals 1 on tan theta. In the olden days, cosec would be written cosec, and in that case, the rule to remembering these was to simply look at the third letter. So the third letter of cot is T, so 1 on tan. The third letter of sec is C, so 1 on cos. And in the olden days, cosec, the third letter would be S, 1 on sine theta. Furthermore, although there's a number of different angles here, they're essentially the same angle in the following sense. Pi on 6 is 30 degrees, 5 pi on 6, or 150 degrees, is actually 180 minus 30 degrees. 7 pi on 6 is 210 degrees, which is actually 180 degrees plus 30 degrees. And 11 pi on 6 is 330 degrees, which is also 360 degrees minus 30 degrees. Trigonometric functions have certain symmetries, so if we can evaluate them for 30 degrees, we can then evaluate them for these other degrees as well. First, a reminder of the definition of sine and cosine theta. We draw a unit circle. We draw a triangle inside the unit circle at right angles here. Because the circle's got radius 1, therefore the hypotenuse here has got length 1. The xy coordinate of this point here by definition is cos theta sine theta, where we've got the angle theta here. While you can also say that sine theta is the height of the triangle and cosine theta is the width, so to speak, keeping in mind that cos theta sine theta are the xy coordinate here helps when theta becomes larger than 90 degrees and goes into these other regions over here. Provided the angle is acute, that is less than 90 degrees, we can also say that sine theta is the ratio of the opposite side to the hypotenuse and cos theta is the ratio of the adjacent side to the hypotenuse. Besides 0 degrees and 90 degrees, there are 3 other angles we can work out sine and cos for exactly from geometry, and they are 30 degrees, 60 degrees, and not covered today, 45 degree. For 30 degrees and 60 degrees, we use an equilateral triangle. An equilateral triangle, by definition, has sides of all the same length. Therefore, the angles are the same in an equilateral triangle, and since angles sum to 180 degrees, that means each angle is 60 degrees. If we drop a perpendicular line, then it will split the base at exactly the halfway point, and it will also mean that the angle here is 30 degrees, half of 60 degrees. For convenience, give the hypotenuse a length of 1. The hypotenuse is the side opposite the right angle. This means that along the base, the whole base is 1 because it's an equilateral triangle. Therefore, the distance from here to the midpoint is 1/2. Finally, to compute the length of the perpendicular, we use Pythagoras' theorem. Pythagoras' theorem says that this squared plus whatever this is squared has to equal to 1. Therefore, this length here is the square root of 1 squared minus 1/2 squared. In other words, the square root of 3 on 2. We can therefore read off that sine of 30 degrees, sine is opposite over hypotenuse, so sine of 30 is 1/2 divided by 1, or just 1/2. Cos of theta is adjacent divided by hypotenuse, in other words, cos of 30 is just the square root of 3 on 2. And finally, tan theta, you can either say tan theta is opposite divided by adjacent, or just have tan theta is sine theta divided by cos theta. In either way, we get tan theta is 1 on the square root of 3. Next, we look at the 3 symmetries we need for solving today's problem. The first one is, can we evaluate sine or cos of 180 degrees minus theta given sine or cos of theta. This is the relevant diagram here. I've got one angle theta for my white triangle and another angle 180 degrees minus theta gives me my yellow triangle here. Remember that for this yellow triangle, the definition of sine and cos of this angle 180 degrees minus theta is given by the xy coordinate of this point up here. In particular, we see that the y coordinate is the same as the y coordinate for the angle theta, so therefore we get sine of 180 degrees minus theta is the same as sine of theta. But for the cos one, for the x coordinate, we see that this x coordinate here, cos of 180 degrees minus theta, is the negative of the x coordinate of this point here. So therefore cos of 180 degrees minus theta equals negative cos theta. Finally, for tan of 180 degrees minus theta, the simplest is just to write it as sine of 180 degrees minus theta divided by cos of 180 degrees minus theta, substitute in these symmetries here to get that tan changes sign. Finally, if you're wondering why these two triangles are just the mirror image of each other, it's because if this is 180 degrees minus theta and a straight line, an angle about a straight line is 180 degrees, that means this angle in here has to be theta. So I've got a triangle here with angle theta and a triangle here with angle theta, and they're both right angles and their hypotenuse is both 1, therefore they're the same triangle just flipped around. A similar thing for 180 plus theta. Here's my triangle with an angle of theta. For my triangle with an angle of 180 degrees plus theta, then the relevant coordinates in terms of defining sine and cos are the xy coordinates of this point right here. But if this has got an angle of 180 degrees plus theta, then the angle here is just theta. Because again, a straight line has got an angle of 180 degrees if you go round it like that. Once again, we see we've got the same triangle here, so the only thing that can happen is that some, or in this case both of the signs, get flipped. In this quadrant over here, sine and cos are always positive. Down here, both the x-axis and the y-axis are negative, so the signs are flipped. So we've got sine of 180 degrees plus theta is negative sine theta, and cos of 180 degrees plus theta is negative cos of theta. Tan theta is just sine theta on cos theta, and so tan of 180 degrees plus theta is just this divided by this. The two sign changes cancel out, so the sine of tan does not change in this case here. Finally, for 360 degrees minus theta, then our two triangles look like this. Again, the triangles are the same, just one's a flipped version of the other. And looking at the coordinate here, we see that the x-coordinate is positive, so cos does not change sign, but the y-coordinate is negative, so therefore the sine term has a flipped sign. Tan, being sine on cos, therefore also changes sign, because only one of these two has got a sign change here. Finally, we can solve the problem. This expression down here is what we were asked to find, and we start off with the angle pi on 6, same as 30 degrees. We can evaluate tan of pi on 6, which we did earlier, by using an equilateral triangle, and we find that tan of 30 degrees is 1 on the square root of 3. Cot squared pi on 6, the third letter of cot is t, so that is 1 on tan. Cot squared is 1 on tan squared of the same angle. We know that tan of this angle is 1 on the square root of 3. If we square it, we get 1 on 3. If we take the reciprocal, we get 3. For 3 tan squared pi on 6, we know that tan of pi on 6 is 1 on square root of 3. When we square it, we get 1/3. When we multiply it by 3, we get 1. So this means that we've computed the first term here, and the 3 tan squared term, we've computed the third term down here. Next, to get the cot 7 pi on 6 term here, we know cot, third letter t, is 1 on tan. 7 pi on 6 is the same as 180 degrees plus 30 degrees. We know from before by symmetry that tan of 180 degrees plus something is just tan of that angle. So that's the same as 1 on tan of 30 degrees, which is 1 on the square root of 3. That is the square root of 3. To get the cosec of 5 pi on 6, cosec, if we write it C-O-S-E-C, the third letter is S, so that's 1 on sine of 5 pi on 6. 5 pi on 6 is 180 degrees minus 30 degrees. From the symmetry of pi, from the symmetry of sine that we worked out, we know that this is just the same as sine of 30 degrees. And from our equilateral triangle, we know that the sine of 30 degrees is a half. Therefore, 1 on sine of 30 degrees is 2, giving us this term here. Finally, we need sec of 11 pi on 6. Third letter is C, so that's 1 on cos of 11 pi on 6. 11 pi on 6 is 360 degrees minus 30. By symmetry, we know that that's just the same as cos of 30 degrees. And from our equilateral triangle, we know that cos of 30 degrees is the square root of 3 divided by 2. So its reciprocal is 2 on the square root of 3. Substituting all these into this expression here gives us this, which simplifies to the answer 8.